Hi, welcome back. In this section, we're going to take a dive into the C in the CAMS model, culture, as we discuss establishing a DevOps culture. We're going to take a look at a number of different aspects that make an organization successful that has an established DevOps culture. Just making these changes isn't enough to guarantee a successful transformation or to master DevOps, but most successful DevOps cultures implement these practices in one form or another. And again, we'll relate these practices that we discussed back to the 3 ways that we started the course with. In this section, we're going to look at a traditional software development lifecycle versus a DevOps SDLC. We'll talk about the concept of service ownership and how that can drastically improve the quality of the software that we deliver. We can talk about hack events and their ability to transform the culture of our company. We can talk about game days and destructive testing and how they can make the difference between an average organization and a high-performing one. And finally, we'll look at agile and cross-functional teams and how they fit into a DevOps culture. In this video, we'll discuss traditional versus DevOps software development life cycles. And to do that, we'll first look at a traditional SDLC. We'll look at problems with a traditional SDLC as we compare them to a DevOps SDLC. And we'll talk about how a DevOps SDLC relates back to the 3 ways. So for most people who have worked in a software development organization, they're pretty familiar with what this looks like. In a traditional SDLC, we have the product organization that decides what the customers want. They write specs and they negotiate with the development team to deliver something. The development team will go and own it. They'll do development, they'll do testing, maybe they'll do one after the other, maybe they'll do them at the same time, but eventually they'll feed whatever they've developed into the release team, saying that whatever they've developed is ready for release. Now the release engineering team is going to feed it into whatever tool chain they have or processes they have in place in order to make the feature ready for release. Oftentimes this means they have to get on a quote-unquote release train where they actually batch up changes so that it all goes out at a single time. When developing on-premise software, this process is even more dramatic because we don't want to saddle our customers with a continual stream of patches that they have to continually apply. Finally, the software is deployed or handed over to operations to deploy. And at that point, operations becomes responsible for the system, for the software, keeping it running, keeping it functioning, all the things that are required. And this piece of software can remain in production for many, many years. With the rise of DevOps methodologies, people started to realize that the place where the software makes money for the company is only when it's running in production. While there's a lot of upfront work performed by development and engineering and release teams, there's no money being made if that work's not in the hands of our customers. To go back to that factory metaphor we talked about, any software that's developed but not released to production, it's like unused inventory in a factory. It's been paid for, but it's not delivering benefit to the company or its customers. This is exactly the reason that Toyota developed just-in-time manufacturing. They didn't want to purchase and store large quantities of inventory that they'd paid for. It was just sitting in a warehouse somewhere. So it's the same thing with our software. The longer our software sits waiting for release, the longer we have to wait to make money on that feature, or find out if our customers will even use it, or find out if there's any problems that we would only be able to detect once the software is running in production. The more the software sits and waits, the more money we actually lose. On top of that, it's not even that the software makes it to production, but the software actually has to run well. We know that if the site's down, our customers can't purchase the product. They can't operate their business. They can't get the information they need. That's what they're paying us for. So now, not only do we have to get our software to production, but once it's there, it has to perform well, it has to have minimal downtime, and it has to keep our customers happy and engaged. So how do we do this? Well, this is the strategic differentiator. That's the DevOps SDLC. In the DevOps SDLC, we don't wait a long time to get our code in production. As a matter of fact, we streamline the delivery pipeline to get our code into production as quickly and as safely as possible. We don't throw software over the wall to QA or operations. We work closely with those functional areas, and we have cross-functional teams, if we're lucky enough, to be able to get the software out into production. In the DevOps SDLC, we recognize that the proper operation of the software is how our company is going to succeed, and therefore, it's at the center of everything that we do, just like we see in the diagram. We can't do that without planning, but after planning, then we do coding, and then we build, and we test. But once the software is deployed, the process doesn't end there. We release the software, and we monitor it as we're operating it, and then we take the results of what we learned, we take the results of instrumentation, we take the results of the performance that we've seen, and we feed that information back into the next planning phase. We're always and continually striving to have the best software running in production as we can, for the benefit of our staff who don't want to be woken up in the middle of the night, and for our customers who expect our software to be of high quality, including security and high performance. So how does this go back to the 3 ways? Well, the first way we talked about increasing flow. If we're working to get our software from our developer desktops into production as quickly and safely as possible, then we're trying to optimize flow. The more quickly we can do that, the more quickly we can get it into our hands of our customers, that's the more quickly that we can actually get feedback. Which is the second way. We had to shorten and amplify feedback loops. If we get detailed instrumentation on the software running in production, the M and the CAMS model, then we can make the necessary adjustments to improve the software. Moving from the traditional SDLC to the DevOps one allows us to do exactly that. That's why at the end of the cycle in our diagram, it feeds back to the beginning. We're always looking to improve what we have in production and use each and every opportunity as a tiny experiment to make our software and our processes better. The third way was about a culture of experimentation and learning from failure, and this is only possible if we can deploy quickly and get fast feedback. Just like we said, the third way relies on the first and the second way. If we batch up large amounts of changes instead of doing small incremental changes, then we're not going to know what's going to happen when the software goes out to production. Would you want to reason about the effect of one change? Or would you rather reason about the effect of 1,000 changes all being applied at once? I know which one I would choose. In the third way, the culture of experimentation is only possible once we've moved from our traditional SDLC to a DevOps one. This video looked at the traditional SDLC versus DevOps. In the next video, we're going to talk about the concept of service ownership. Just like how the DevOps SDLC differs from the traditional SDLC, the concept of service ownership is a way to radically change the culture of our company and how our software is operated and delivered.